Our first Boyle's Law problem is found on slide number 6. Okay, and just for reference, remember Boyle's Law is that your initial pressure and volume, that product is equal to the product of your final pressure and your volume, okay, or P1 times V1 equals P2 times V2. Okay, all your info about Boyle's Law is also found on slide 6. Oh, I'm sorry. The actual problem, is on slide number 7. Okay, so the problem reads, if a 1.23 liter sample of a gas at 53.0 torr is put under pressure up to a value of 240 torr at a constant temperature, what is the new volume? Okay, so with gas law problems, the best thing to do, you guys, is list what do I know, what do I not know. Okay, convert everything before you plug it into the equation to the appropriate units. Okay, and then these are really just plug and chug problems. The hardest part of these is remembering which gas law is which and which one do you use when. Okay, so here we go. If a 1.23 liter sample, that's our initial volume, right? 1.23 liters. Okay, volume is in liters. That's good. That's the unit we want for volume. Okay, is at 53.0 torr. That's a pressure unit. Our initial pressure is 53.0 torr. Okay, but remember, we don't want torr, we want ATM for all of our gas law problems. Okay, some people say, well, you know, if you're converting all your pressures to the same unit, why does it matter? Because these are really just proportions. Okay, trust me, do what I say. In future problems, you always want to be in ATMs anyways, so let's just get in the habit of converting to ATMs right now. Okay, so let's just do that real quick. No biggie. You know that 1 ATM is equal to 760 torr. Okay, so 53 torr is equivalent to 0.0697 ATMs. Okay, our final pressure, right, it's being increased to 240 torr. Go ahead, convert that one too. 1 ATM, 760 torr. Okay, our new pressure is 0.32 ATMs. Okay, and we want to know what is the final volume, or what's that new volume going to be. Remember, something important to help you check your work here for Boyle's Law. As one increases, the other decreases. Okay, pressure and volume are inversely proportional. Okay, so our pressure is increasing. We should expect our volume to be decreased or lower. Okay, so it's going to be less than 1.23 liters. Okay, so we know 3 of our variables. We have to find the 4th one, plug everything into our equation. Okay, so we get P1, 0.0697 ATMs times V1, 1.23 liters, equals P2, 0.32 ATM times V2, which is our unknown. Okay, rearrange everything here, rock star, some algebra. Okay, not too challenging. We get 0.0697 ATMs. Please excuse my stupid dog. 1.23 liters, so that's P1, V1 divided by P2. Okay, look at what's happening with our units, right? Atmospheres divided by atmospheres cancels out. We're left with liters. That's a volume unit. Bingo, bango. That's what we want. Okay, crunch some numbers. Round to 2 sig figs. You get 0.27 liters as our final volume, and just verify, yes, it matches what we predicted, right? Pressure is increasing. Volume should decrease. Cool beans. Good to go. Okay, let's try another one. This problem is on slide number 8. Okay. This problem reads, the pressure on a 411 milliliter sample of a gas is decreased from 812 millimeters of mercury to 790 millimeters of mercury. What will the new volume of the gas be? Okay, so again, Boyle's Law, P1V1 equals P2V2. Okay, so our initial volume is 411 milliliters. Red flag, you want that in liters. Quick metric conversion, right? 1 liter contains 1,000 milliliters. If you're rusty on those, you got to refresh. Okay, we have 0.411 liters of gas as our initial volume. Okay, our initial pressure is 812 millimeters of mercury. Do what I say, convert to ATMs right off the bat. You know that 1 ATM is 760 millimeters of mercury. Okay. So our initial pressure is 1.07 atmospheres. Okay, and then they're saying we decrease our pressure to 790 millimeters of mercury. Okay, again, convert. Okay, so our final pressure is 1.0 atmospheres. Okay, we see our pressure is decreasing. We should expect our final volume to be increased, right? Because we set up in here in number 7, or on slide 7, sorry, the pressure and volume are inversely related. Okay, so our pressure is decreasing, we expect our volume to increase. Okay, rock your algebra. P1 times V1 equals P2 times V2. Okay, rearrange, do your algebra. Okay, again, verify atmospheres cancel out. You're left with liters, which is what we want. Do this, round to 2 sig figs, you get 0.44 liters. Okay, remember our initial volume was 0.411 liters. Our volume did increase as predicted. Okay, or if you want, you could convert back to milliliters just so it matches the problem. Okay, this would be 440 milliliters. So Boyle's law, pretty straightforward. Again, the hardest thing is figuring out which is which, initial versus final. Okay, that's just reading comprehension. And then making sure your units are what they need to be. So for volume, we want liters, pressure, we want atmospheres. Okay, so next video coming up is going to be Charles' law. Stay tuned.